we are going to be creating a fourth degree polynomial. And the process we're using here can actually be generalized. In particular, we're doing a fourth degree because that's what's given in this example. So you could do it for any degree. And just depending on the zeros and degree, you would, obviously adjust the process, but it can be extrapolated out further. In our case, we've been asked to form a polynomial f of x with real coefficients having degree 4, and it has zeros -4 plus 2i and -4 with a multiplicity of 2. Now, a fourth degree polynomial should have 4 zeros. So far, there's only 2 listed, but we know 3, and we're going to use a theorem in a second to go ahead and find the fourth. So initially, we know 1 0 that is complex. That is our, I'm going to zoom in a little bit here just for my rating. That is our -4 plus 2i. We also know another 0 is -4. Well, because of this multiplicity of 2, that actually means that particular 0 is going to appear twice. So now we have 3 out of our 4. To find our fourth, we are going to use the conjugate pair theorem that's listed right here. And it says, let f of x be a polynomial whose polynomial function whose coefficients are real numbers if r equal to a plus bi is a 0 of that function, then r equal to a minus bi is also a 0. So basically, if you have a complex number that is a 0 for a function, its conjugate will also be a 0. So taking this information, a complex number, a plus bi, that's one of my zeros, then its conjugate, a minus bi, will also be it. So our example, we have -4 plus 2i. So that means -4 minus 2i will also be a 0 for this function. So we now have all 4 needed zeros, right? Here's 1, here's 2, and then again, we have our 2 4s that we talked about earlier, okay? Or the -4s. So now we can use the factor theorem to go ahead and take our zeros and rewrite them as factors of our function. So this theorem says that if we have a polynomial function f of x, and it's an if and only if, and so we're actually going to use it in reverse, but I'll read it to you in this form first. X minus c is a factor of f of x if and only if f of c is 0. Well, if and only if statements work in both directions. That's what the if and only if means. So we're actually going to use this in reverse. I'm going to zoom in a little. And we're going to say, hey, if I know f of c is a 0, so like for our example, f of -4 is a 0, then I can say that implies x minus c is a factor, or x minus my -4 is a factor, okay? So there's a minus that comes from the formula, and your c is just going to be whatever zeros we have, okay? And that's going to be the general form. And we can actually take this a little further. So we're going to kind of put this together, and then we're going to fill it in. If we're looking for a fourth degree polynomial, I apologize, I'm coming down here and make sure I have room to write. Then what I want to do, and I'm going to erase a little of that just so it doesn't get in our way in a second. I'm going to have f of x, and I'm going to put an a here for the coefficients that could be in front. But I know that we're going to have x minus the first 0. You're going to have x minus its next 0. And we expect to have, we're going to have 4 of them for our fourth degree, okay? And then I'm going to erase a little of this just so that it doesn't get messy. And we're going to look at what's this off. But we're using that same logic. We're going to say plugging in our values. Now keep in mind this subtraction comes from the formula. We're going to plug in our function will be f of x equals, keeping our a in front, x minus, and again, I'm going to do my -4. There are two of them, so this will appear twice. Okay, moving over a little bit. I'm going to list my two complex next, and they're right here. So, and when you do the complex, I'm going to go ahead and use a bracket because I kind of see what's coming, and I'll do these in pink. Why not? X minus, and I'm going to put parentheses around this as well. And I mean, you could put brackets over here. I don't know. I didn't stress as much about it, but these we are going to need to do some distribution. And really, there's a couple of ways to proceed from here. We're going to talk about them. Let me focus and make sure I write these correctly. So I have my x minus, and now I'm plugging in my 0 that we just talked about. So we have a -4 plus 2i. It's always good, just pause, double check, make sure we did it right. X minus my -4 minus 2i. Okay, I'm going to zoom out, kind of look at what we've got. So we're going to do a little bit of zooming in and out just to make sure everything kind of fits, because this is a lot of writing. So we have our first 0, which is our -4. It's twice because of that multiplicity of 2. Then we have our x minus. We have our first complex that was given, and we have its conjugate pair, or its conjugate over here. So that pair is going to be here. So one's here, the other's there. Okay. And I'm going to go ahead, and these two I would go ahead and simplify before I do anything further. And I will go to another slide, but I'll pause briefly before I do that. When I go to the next slide, just to kind of show you how the rest of it will proceed, I'm going to start with both of these being positive because of that double negative. Okay, so I'm going to pause real quick and we'll pick it up. You won't even probably be able to tell, but I'm going to take all this work to a new slide, and we are going to go ahead and simplify this to get our polynomial. Okay, so we have moved over to a new slide so that we can go ahead and simplify what we have left. I did go ahead and change my x minus -4s to x plus 4 for both. And now what we need to do is we need to multiply all 4 of these together to get it in a generic polynomial form where you're going to have your x to the 4th, your x to the 3rd, x squared, and so on terms listed. Not in the factored form, but in the expanded form. Okay, so there's a couple of ways to do this. I'm going to do this problem. I'm also going to do a second video where I'm actually going to work the reverse, where I'm going to find the complex zeros, and then I'm going to multiply to check them. So I'm going to do each of these two videos in 2 different ways. So if you want to watch it, I'll try and make sure that these two are linked together so you see it. This one, what I'm going to do, and you can pick anything you want to do here, really, as long as it's mathematically sound. I choose to multiply these two together first. You know, this is a perfect square trinomial. This is one of those factor forms that maybe you've memorized, but you can also just FOIL it. It's pretty straightforward. On the second part over here, there's a couple of options here as well. So you can, same thing, recognize that these two, we could multiply and treat this as like an A minus a B, and then you can multiply this like a 4 term and work it that way. Or we can distribute this and you're going to be multiplying 2 trinomials together. I'm going to go ahead and do the trinomial method on this one. And on the next video, again, I'll make sure you see that. I'm going to actually multiply the other way where we treat it as these are each 2 terms and multiply. So it's just kind of interesting to see how the two work. And I mean, again, pick a method that you enjoy or that you understand and just stick with that as you're multiplying. That way you're practicing and you're getting that repetition. So I'm going to go ahead, like I said, I'm going to multiply these two first. So I'm going to leave my f of x and my a kind of hanging out for a little bit. Towards the end, we'll bring it all back together. But I'm going to do my x by x, and I will get an x squared. I will multiply again x by 4, and I will have 4x, which are positive. Again, 4x, that is positive. And last, I will have plus 16. I'm going to finish up this one in blue and have x squared plus 8x plus 16. Now, keep in mind, all of these are being multiplied. So when I get done, or even right here, I really need to remember that this is all a multiplication problem. So make sure you put this back in parentheses, this trinomial that we obtained, so that we remember when we get done with the purple that we're going to multiply those again. Okay? So next, like I said, there's a couple of ways you could do this. I am going to go ahead and first distribute here and rewrite this as x. Now, negative times a negative 4 will give me plus 4. Negative times a positive 2i will give me negative 2i. And that's fine. It doesn't really need the brackets anymore, but since I had them, I'm just going to leave it. It works the same as parentheses. For the next one, I'm going to do the same thing. Keep my x. I'm distributing that negative, and that will become plus 4 plus 2i. And again, multiplying, as long as you're multiplying each term by every term, like each trinomial or binomial, whatever you have, fully, you should be fine. You can use different types of distribution. Just make sure that you are fully doing the multiplication process. But you can multiply things in different orders depending on your choice, and you can still get the right answer. Now for this one, what we're going to do now is we are multiplying these 3 term by this 3 term. So to really kind of keep it neat for myself, I am going to move over, keep this only on the screen, and really just focus on these 2, leaving the blue until we get done. So just, it's easier sometimes just to view it as pieces, and then that you're less likely to make mistakes that way too, right? So focusing on this, I enjoy using colors to help me. I'm going to take my x, and it is first going to multiply 1, 2, 3, okay? X by x gives me x squared. X by 4 gives me plus 4x. X by 2i gives me plus 2ix. Okay, I'm going to pause, double check my work. We want to take this really slow, being very close, paying very close attention to detail, okay? Nothing worse than doing these really long problems and having to start over because we made a mistake. Next, we're going to take the second term in the first polynomial and multiply it by, again, all 3 in the second, okay? Positive 4 by x gives me plus 4x. Notice I'm lining these up underneath each other. This is a strategy that I like to use to help me because I will need to combine all these terms after I multiply. So 4 by 4, that's going to give me 16. I'm going to move 16 over here because that's not matching any of the terms I had above. But 4 by 2i is going to give me plus 8. Oh, I'm sorry, that's 8i. There's not an x there. Be careful. Plus 8i. And that's okay. Again, mistakes sometimes happen, but as long as we catch them. So, and it wouldn't have necessarily been a mistake. My multiplication was correct. But if I want to line them up, I'm trying to kind of match like terms just to make it a little easier on myself because we are going to have a lot of things that we are combining here in just a minute. For my last multiplication, I'm going to be very careful because this is a negative, right? I'm going to do it slow. Negative 2i by x. That gives me negative 2ix. Wonderful. Oh, let's not put it there. Lower down one. Negative 2ix. I got excited because I see some cancellation. Negative 2i by 4. So that's going to give me negative 8i. Look at that. Some more cancellation. And negative 2 by I by positive 2i gives me negative 4. And I have an I squared. I'm going to go ahead and handle this real quick like negative 4i squared. So that's negative 4 by negative 1, right? Negative 4 by negative 1 will give me a positive 4. So I'm going to kind of mark this out. I'm going to replace that with a plus 4. Or even better, let's just go ahead and line that up under my 16. Okay. So hopefully we are all still here together. Let's see how this is going. We have an x squared term that is going to come down. We have plus 8x. I have 2i terms here, the xi, and they're equal and opposite in sign, so these two will cancel one another out. Similarly, my 8i's are going to cancel one another out, and I am going to be left with plus 20. Okay. So far, feeling pretty good. So that's going to be, I'll zoom out a little. That's going to be the multiplication of those two purple parentheses. So when we get done, we get down here, we're going to have x squared plus 8x plus 20. All right. So we have our f of x equals a is going to be times this first trinomial times the second trinomial. And so we're getting there. We're probably going to need one more slide. So let's do this. What we are going to do, I am going to clear a little space right here. Okay. So we know we have this minus 4i squared. I'm going to go ahead and erase a little bit of this right here. Please don't get too concerned about that. We've simplified it. And we know what that part is. Here, just give myself a little bit of room to do my last little bit of trinomial work, okay? So if you need to, pause, make sure you've written all that down. And I'm just going to make sure that I've kind of wrong section, giving myself a little bit more room. So we have one more trinomial that we are going to multiply. Okay, so we've taken our, and I'll zoom out if I can just remind you, we've taken our two zeros that were -4, multiplied those to get this 8x, x squared plus 8x plus 16. We've also multiplied our two conjugate pairs together and obtained x squared plus 8x plus 20. I just wrote it up over here so that we can go ahead and do that multiplication. I am going to erase this -4i squared that we've already handled. So that won't be there. We've already talked about that, so you're okay. I just want to give myself a little more room as we proceed towards the end, okay? So zooming in on this is our last multiplication. We have a 3 by 3. So just a good rule of thumb as we're multiplying, same thing that we did on the last one. I'm going to use colors, but you expect to get out 9. I'm going to let the a and the f of x just hang out until we get done. So I'm going to take my x squared from my first, multiply by each of the terms in my second trinomial over here. I'm going to obtain x to the 4th plus 8x cubed plus my 20x squared. Okay, and again, I like to just double check as I go to ensure I didn't make any mistakes, particularly if I'm talking like I am right now. Next, I'm going to take my next term and multiply it by everything as well. So 8x by x squared gives me plus 8x squared. And again, I'm going to line them up to try and help myself. 8x by, I'm sorry, that was 8x cubed. See, when I'm talking, sometimes so 8x by x squared would be plus 8x cubed. Okay, 8x by 8x will give me plus 64x squared. And finally, 8x by 20 will be plus 160x. And again, let's just double check. So you have 8x with an x squared with a cube. Excellent. 8x and 8x, 64x squared. Good. 8x and 20 is 160x. And now for my last multiplication. We are nearly done with this very long problem. 16 by x squared will be plus 16x squared. 16 by 8. I do not know this off the top of my head. Handy dandy calculator to the rescue. 8 times 16 gives me 128x. And last, 16 by 20. So I can do this in my head, but at this point, we've been doing a lot of math today. So I am going to do it on my calculator. I put that in. I got 320. And now let's go ahead and add up and see what we got. So I got, bringing this down, x to the 4th plus 16x cubed. Please do not add your exponents. When we're adding like terms, we only add the coefficients, right? I know sometimes when we do this like stack addition, I think maybe that makes it a little more tempting, please don't do that, right? So 20, it's like saying I have 20 x squared. I'm adding 64 more of them, plus 16 more. Altogether, I have 100 x squared. And over here, what is this? 288, sorry, that did not, right? In x and 320. Okay, when you're doing these, this one, oh, what did I forget? I forgot my A because I was talking. When you're doing these, and you want to check it, I recommend a good app that I like to use or a good website would be Wolfram Alpha. So I like to do that just to kind of check my work sometimes. So maybe we'll do that and see how we do. Give me 1 second. All right, so I have loaded up that site. So what we're going to do, just to kind of check, if you want to check and make sure you've done your problem correctly, if it's like you're doing it at home for yourself. So we had, you can't really read it up there, can you? We had a times x to the fourth plus 16x cubed plus 100x plus 288x plus 320. So we want to see if we did this correct. Again, I recommend Wolfram Alpha. I'm going to go all the way back up to here. And I'm going to type this in, just double check, make sure, see how I did. So I'm going to show you this site. See if it'll, I'm going to show you my desktop real quick. Okay. So this is going to be what we're looking at. And I'm going to plug in that equation that we had. So it was x plus 4. So I like this site for a couple of reasons. It's going to give you a little more information than maybe some of the other ones. It's something that I actually used when I was in grad school because sometimes we didn't do things like this by hand. When you get a little higher in courses, the solving part, it's important, but even more important is understanding the application and being able to interpret data. So this was our x minus our negative 4, our x minus our negative 4. So those were our two negative 4s of multiplicity 2, the zeros we had. This was our first, I think we were given the positive initially, the complex. This is the other one. You can use this, just to check and make sure that, you did it right. Let's see. What do we get when we expand that? Okay, look at that. And that is what we got. All right, I feel pretty good about this. So I just like this site, thought I'd show you. And you see we got options here. It's using I as our imaginary unit, which is what we want. Very smart of it. It could change it to a variable. So there's some cool things on this site. Just thought I would show you. But all right, great job and thank you.